Okay guys, so in this video I'm going to be talking about my PCB design as well as my CAD model for the case, both for the AlbBoi project. So we're going to start off with the PCB design. If you want to see the schematic design or the bill of materials, go check out the previous episode. And yeah, once you've checked that out, like the schematic will pretty much make sense to you. And the PCB design is basically just the schematic remade for a board layout to be printed. So that's basically what this is. It's all the same components, but I thought I would share with you guys what I have so far. So as of now, what I have is a board with one internal layer, and then obviously I have the top layer and the bottom layer. So for those who don't know, the top layer is noted with the red sections, and then the bottom layer is the blue section, and then I have an internal layer which is currently being used to connect all of the VCC, VDD, like all the power throughout the board. And then ground and every other signal is connected through wires on the top and bottom layers at the moment. So yeah, as you can see from this, the only through-hole component is the header component over here that's going to be connecting to the LED screen, and everything else is surface mount devices. This was mainly because of the constraints given to us by our professor, but depending on how this goes, it really doesn't matter to me one way or another. But if it seems like we're not going to be able to go back to school in the fall, at least not in person, I will probably shift these all over to through hole. That way I could solder this on my own from my room, as opposed to having to try and do this on campus when I don't have access to the lab and stuff like that. So yeah, alternatively I could always just order the board with the parts on it, but that causes some constraints in terms of what I can put on my board, but also in terms of like whether or not, like in terms of pricing as well. So that'll like skyrocket the pricing, and reducing cost does make sense for me at this moment, because this is a personal project and everything too. So yeah, as of now, I am going to keep the surface mount components as well as the through-hole component just as they are, but in the future, depending on how the fall situation looks like for me, I may shift everything over to through-hole, or at least for the most part, just to make things a little bit easier for myself. But yeah, so just so you guys understand exactly what's going on here, and I do believe that this layout is going to have to change, because when I looked at the 3D model, which I will show you in a minute, there were some issues with where things were placed in terms of how they would look and how usable I think the device would be. So, for example, this is the programming device, the JTAG, which needs to be visible from one of the exterior walls. So I would say that in fact this device here needs to be changed to be something at a right angle device. As of now, the device is just going to sit, or the connector is just going to sit directly on, and it's going to be a regular straight surface mount device. So if I can find a right angle surface mount component, then I would grab that and put it somewhere along the edge and connect it that way, just so it would have easier access through the case, and I could build the case around that connection there. Similarly, the location of the LED is right here, and you can't really even see it, but it's right here. And I would probably prefer doing something similar where it's on the side, probably right next to this connector as well, so that they're both just there. And then same thing, I might want to search for a right angle surface mount device. So that's another issue that I've noticed from when I created my 3D model, for what could definitely be an issue once you have a case surrounding this board. Now, for the buttons themselves, I think that overall it's fine. The main thing is understanding the dimensions of this. So as of now, I do want to reduce the size to be within 100 by 100 millimeters, I believe, because once you exceed that amount, the cost of production increases a lot. So trying to get different revisions of boards could be a lot more difficult if it's a lot bigger. I think that with the placement of this connector here, it really depends on looking at what the actual location of the connector would be for the screen. So yeah, that's pretty much all I have to say for here. There's definitely some issues in terms of switching out some components to right angle components. I just think that would be a little bit easier to do, or a little bit easier to work with in terms of once I enter the testing phase for this project. So I think that's one thing that I should be looking into. And then the other thing is making sure that the sizing for the entire board just makes sense with everything else. And just so you guys are aware, I don't think I mentioned this in the last one, but these are the action buttons for the Game Boy, and these are the direction buttons, and then these are the two buttons that I believe one is start, and I forget what the other one is. I'm kind of blanking on that, but yeah, if you've ever used a regular Game Boy, you know what I'm talking about here. So basically, this is like on its side. It's if you were looking at the device as at a regular Game Boy, it's kind of like if you rotate it 90 degrees to the left, or clockwise, I mean. So yeah, that's pretty much what I have here. So we're gonna now move on to the CAD model. So this is the case itself as I have it right now. As you can see, there's giant opening here, mainly just so I have easy access to the tactile switches, but I think in the future I do want to end up having this entire section covered and just having holes for the buttons. Initially, I wasn't really sure how to create what we consider physical buttons that we would see on a device, because what you have on regular switches are things that are just connected to the PCB device, but you need to have a mechanical piece on top of that, which is what the user would actually be touching, what the user would consider their button. So that includes getting like springs, potentially. I really need to do more research on exactly what goes into that, and then I would also have to 3D model what those buttons would look like as well. So yeah. Now, from here, I also just want to discuss exactly what's on this board. So there are a couple issues with how I made this casing. So first off, this, I believe, is the actual schematic, and I shouldn't have added in the screen here. So this was a pre-made screen model that was given to me, and this is the actual board that you're given. Oh, I can't really grab that. Let's see, I can just show it to you by itself. Yeah, so this is the actual board itself, and as you can see, there are some other components that I added onto here. There were some issues with exporting the board from Eagle, so what I ended up having to do was just grabbing the other designs that I had and just placing them on just to get a general sense of what the device looked like. And that's kind of the issue that I have here. I really should have just created another component or another file here and then copied over the PCB over to there and then placed the other components on top of that there. So that's one thing that I do need to fix, because this component here is directly connected to the Eagle device, and I have no clue if adding things externally is going to impact or cause issues with the connectivity or the syncing between the two files. That's something that I'm just not sure about, so I do need to fix that in some way. And as you can see, I do have the other different components here. This is one of the this is the JTAG connector here. It just has like a little case looking thing on top of it. This is the microcontroller. This is the board, or this is the LEDs board. Not LEDs board, sorry. This is the screen board. And then this over here is just a giant block that I made to represent the other header component. The device didn't come with a pre-built 3D model, so I just needed something to generally describe the height of the device. So yeah, that's pretty much everything that I have here. And from here, I do also want to discuss rotate. I do also want to discuss what changes that I do want to make here. So first off, I need to find 3D models, or actually make 3D models for the switches themselves, for the tactile switches that lay on the PCB, and then I also need to create a 3D model for the mechanical buttons that would be sitting on top of that. So I need to do some research on exactly how that stuff would work. Cancel that. I do believe, yeah, I also need an LED component as well here too, just to make things like partially just for completeness, but also I just think it's a good idea to have all the components there so you always have like a general idea of the sizing of each piece on the board. So yeah, apart from that, obviously if I make changes to the schematic as well as the PCB design, this schematic, or this 3D model of the PCB, will also have to be altered for that. As such, I'll be working on the schematic first, as well as the PCB design, and then coming back to this at the very end. Now, back to the case real quick. So, as you saw here, this is like how the entire component's going to be. So what I need to add are holes here so that I could add some type of screw once this is printed out. And then I also would have to add a small hole here wherever the JTAG connection as well as the LED would end up being as well. So those are the main changes that I know will be taking place at the moment, and obviously the covering of this case as well. So yeah, that's pretty much everything that I have for this video. If you want to take a look at these models yourself, both the Eagle schematic, the Eagle PCB design, as well as the Fusion 360 design, they're all located on my GitHub. And on top of that, you can take a look at the bill of materials, and I do also have some screenshots listed in my GitHub as well. So yeah, that's pretty much all I have for this video. I will see you guys in the next one, where I will be actually making some changes to the schematic design, doing some research, things like that. And then from there, I'll move forward with the project. So yeah, hope you guys enjoyed. See you guys in the next one. Thank you so much for watching this video. I really appreciate it, and I hope you guys enjoyed. Please be sure to let me know what you guys thought in the comments below. Leave a like to show your support. And subscribe if you want to see more from me. And I will see you guys in the next one. Bye.